So here in this video, we'll discuss what happens when ozone is treated with alkyne. So here alkyne plus ozone. Here simply alkyne means acetylene. I am taking alkyne means it is a triple bonded compound. So here alkyne, ethyne I am taking. 2 carbons, ethyne, triple bond is there, no? So when it is treated with ozone, under these conditions, ozone hydrolysis, it will be this condition is called as an oxidative cleavage. So here how to write the product? Here you just simply cleave these 2 pi bonds, and here CH, single bond CH, and instead of that 2 pi bonds, you place 1 oxygen here, 1 oxygen here. So here I am writing C double bond O, C double bond O. That's it. So here simply for our convenience I am placing hydrogen, writing this hydrogen with a bond. Okay. So if under these conditions it further undergoes cleavage, oxidative cleavage. Here breakage of this bond. So breakage of this bond, and here it is break to acid. Here this triple bond, instead of the triple bond you break the triple bond, 1 oxygen to this carbon, 1 oxygen to this carbon. So it undergoes further oxidation, forming, you write HC double bond O, OH plus OH C double bond OH, formic acid. These are the conditions. This is 2 moles of formic acid are formed. These are the conditions of oxidative cleavage. Same here, if this ozone is treated with, I told you, no, zinc or zinc acid or dimethyl sulfide, or second, this is the first one, this is the second reagent, and the third one lithium aluminium hydride, LaH or NaBH4. This is the reductive cleavage. These are the reducing agents. Okay. So here under these conditions, here it will be you try to remember these two, and this will be for your JE exam. Okay. So here when ozone, one alkyne is treated with ozone, so first CH, simply as it is formation of a diketone, break that one. Here is your C double bond O, C double bond OH. And if you use one of these reagents among these 4, here they will be further. Here it is, for example, here in the second one I am taking dimethyl sulfide. Here it is, these are the reducing agents, no, here. So here break this bond, pi bond, and the addition of hydrogen to this pi bond. So you are breaking this pi bond between this carbon and oxygen, no. So between to that atoms you add 1 hydrogen to this oxygen, 1 hydrogen to this carbon. Similarly 1 hydrogen to this one, and 1 hydrogen to this one. So what you will get here? Here they are, here this C double bond O is reduced to alcohols, diols you will get, CH. Here CHOH, like this. This is the way of writing product under these 2 conditions. It is the ozonolysis of alkynes. If alkyne is treated with ozone. So here the formation of ozonide and all, they are common. So here how to write the product? You just cleave the bond, and here you are breaking the 2 pi bonds. So 1 oxygen here, another oxygen here. So under the oxidative conditions, here it will be further, the carbon bond will be cleaved, and here you will get acids, and here if it is a reductive ozonolysis, you will get diols. Okay. So I'll give you another example. Clear this one? So if we take CH3 C triple bond C CH3 plus ozone. Here in this example I will write the ozonoid formation. So here you introduce oxygen in the pi bond, I told you, no? So unlift that bond, C double bond O, C, CH3. Here is your CH3, one bond as it is. And here oxygen, oxygen. This is similar to alkene, but here in the alkene there is no bond between this carbon and carbon. So each carbon got one bond, no? Each carbon got 4 bonds, no? So that's it. This is the ozonoid formation in the case of alkyne. Now here, if it is H2O, it will undergo oxidative cleavage. So here how to write the product under these conditions I told you, just break this bond. And here simple way of writing the product, here it is your CH3. Here is your C double bond O, C double bond O, CH3. So here if it is an oxidative cleavage, ozone plus H2O, here you break this bond also, OH here, OH here. So what you will get? You will get 2 moles of CH3, COOH. That's it. Okay. So here the same ozonoid under the conditions. What are the conditions? Here it is a dimethyl sulfide you take. Okay. So here this will be formed 2. Here in both the cases this will be formed commonly. So here CH3 C double bond O, C double bond O, CH3. So here when it is treated with dimethyl, if you take this one, so here in both the cases the product till here the product is same. But if it is an oxidative cleavage, there is a breakage of this carbon-carbon bond forming acid. And if it is a reductive cleavage, you just break this pi bond, hydrogen to oxygen, hydrogen to carbon, hydrogen to oxygen, hydrogen to carbon. And here you will get a diol, CH3, CHOH, CHOH, CH3. It is ozonolysis of alkynes. Clear? This is ozonolysis of alkynes. So just you remember the conditions. If you practice, you will get everything. Okay. And this is about ozonolysis of alkynes. This will be useful for your boards till now. Okay. So in the next class, I'll discuss what is Wood's reaction. Okay. Till then, bye.